In this video, we're going to do another example of using node voltage to solve a circuit. However, in this one, it's going to be a little more complicated because we are going to need a supernode. So let's start with the same as any other way. When you have node voltage here, you go ahead and identify what nodes you have. We have the node on the bottom, that's 1. You can say there's 2, 3, and then 4. So we have 4 nodes here, 3 variables. And go ahead and put our ground wherever we want to. As we've seen before, we want to put our ground on a node that has voltage sources because it makes our life easier. For example, if we go ahead and put ground on the bottom here, then we would immediately know that this first node is going to be 21 volts without doing any work. On the other hand, if we don't like that choice, we can go ahead and put ground, let's say, over here. And if I choose ground to be that node, then this right top node would be now 9 volts. However, I want to point out that regardless, whichever way we choose our ground here, we still are going to have another voltage source that's connected between 2 nodes that we don't have the value for. Like, for example, if the bottom is ground, which is what we're going to actually use to solve the problem, we figure out 21 volts can go right here, but we have this 9 volt voltage source up there, and it's between 2 nodes. And neither one is ground right now, so we cannot just say that one side is 9 volts. You can only say that if one side is ground. So because of that, you might say, let's go ahead and do node voltage here. So let's make our variables. We know one's 21 volts. I'll pick this node to be V1 and this node to be V2. Now if I try to do Kirchhoff's current law at V1, I've got current going left, down, and right. And I say, okay, how much current is going to the left? That's voltage you're at minus voltage you're going to over R. And how much is current going down? That's voltage you're currently at minus voltage you're going to over R. And then I have to add the current going right. And you might say, why am I writing this out here instead of just using my formula? Well, what is our formula that we've been using? Our formula for current is I is V you're at minus V you're not at over R. That comes from using Ohm's law. That's how you find the current through an object using Ohm's law, V equals IR. But the problem is here, this current that is going right, I cannot use Ohm's law to find it. And the reason why I can't use Ohm's law to find it is because it's not a resistor. There is no nice formula that's going to tell you what the current is when you have a voltage source. We only have this nice formula that tells you what the current is when you have a resistor. So guess what? We get to this equation here and we're stuck. Because we have our variable V1, but we also have this right current that we have no idea what it is. Now you could go ahead and treat it as a second variable, like y or whatever other variable you want to use here. But then you'd have 2 variables, you would need 2 equations. And again, there's nothing wrong with that. You could do it that way, but there's going to be a technique that we're going to realize here is that whatever current's going right, it's actually going to keep going through the voltage source, and it's going to enter this other node here. And we know from Kirchhoff's current law that whatever current's coming in here is going to be the same as the current going down and the current going right on that side. So what we're going to do is we're just going to replace this here using Kirchhoff's current law there. So we still have the V1 minus 21 over 4 and the V1 minus 0 over 3. And then I say, okay, well, what's the current going down? Well, it's voltage you're at minus voltage you're not at. It's going down, V2 minus 0 over 2. And the voltage going right is, again, voltage you're at minus voltage you're going to over R. And this is going to equal 0. And again, the reason why we got that expression there was we knew Kirchhoff's current law that whatever current's going right is going to equal the sum of the currents that are leaving the node. Now here's what we're really going to do in the future. Whenever you have this voltage source in between them, what you're going to go ahead and do is you're just going to pretend it's not there at first and just say, okay, this whole thing is just one supernode, and you want to look at all the currents leaving it, and there's going to be one current left, one current down, another current down, and another current right. So you're going to have 4 currents leaving that big green supernode, and that's exactly what these 4 terms are right here. With that said, we now have 2 variables, so we're going to need a second equation. And whenever you use a supernode, the second equation is going to relate the 2 ends of your supernode and say what the difference is between them. And just so we can see the actual source here, if you look at the source, if you start at V1, there's going to be a 9-volt gain before you get to V2. Or in other words, V2 is the same as V1 plus 9. And once we have that, we can go ahead and substitute what that is into our equation here. So we're going to replace our V2s with V1 plus 9. Sorry, it's not 8, that is 3 here. So V2 is V1 plus 9 over 2 plus V1 plus 9 over 6. My common denominator here is 12. 4 goes into 12 3 times, so 3V1 minus 63. 3 goes into 12 4 times, 4V1. 2 goes into 12 6 times, 6V1 plus 54. And 6 goes into 12 2 times, 2V1 plus 18 equals 0. Go ahead and combine here. 3 plus 4 is 7, plus 6 is 13. That's going to be 15V1. Then I have, let's see, negative 63 plus 54 is negative 9. Plus 18 is plus 9. Move it over. It's going to be a negative 9. And my V1 then is negative 3/5, which is the same as negative 0.6 volts. Then we have to go back and figure out what we're actually looking for. So let me clean this up a little bit over here. We have our V1, and we're trying to find the voltage to this resistor. Well, V is going to be the voltage on the positive side minus the voltage on the negative side, which is 0 here. So V is going to be the same as V1, negative 0.6 volts. And for my current here, it's going to be using Ohm's law, the voltage drop divided by R. And so the voltage on the positive side there is actually V2, minus the voltage on the bottom side is ground, over the R is 2. Now, what is V2? We know V1 is negative 0.6 volts, and we know V2 is that plus 9, so it's going to be 8.4 volts. So we're going to have 8.4 volts divided by 2 ohms. So my I is going to be 4.2 amps. So we found our voltage and our current that we were looking for using node voltage.